to jump in then, the current state of data engineering today, there's quite a few tools out there. And I guess what I was just mentioning, I'm going to set the stage for how Dagster came to be, and then we'll jump into that live demo. But there's a lot of tools out there, and this makes it difficult when things break, that you have to potentially splunk through multiple tools to find out the root cause. And in a lot of the other popular tools out there today, there's just not a lot of context when you're running from a task view of the world. In this example, the run dbt kind of run step there essentially has a whole nother DAG concealed within that run step itself. And this leads to teams being siloed and not adopting or standardizing on common tool sets. And part of this reason also is due to the lack of having a great dev experience. And for all of these reasons, this kind of led to the creation of Dagster. And that said, Dagster is a data orchestrator built for the entire data lifecycle. And that means that testing as a first-class citizen, you're able to run and monitor all your computation, and you get end-to-end lineage with rich metadata to help you manage, troubleshoot when things go wrong, as I mentioned before. Dagster was really created to help enable software engineering best practices. And it's able to do that because the core abstraction is a software-defined asset or a data asset, versus in some of the other popular tools out there, the core abstraction is a task. And why that matters is because when things break, it's easier to make a connection to the things your stakeholders care about. So like dashboards, for example, when a dashboard breaks, or if someone comes to you and says, hey, how did you calculate this field? You're able to do that a lot easier with a data asset view of the world versus the task kind of paradigm. And those data assets are what you end up automating in your pipelines. And there's a few different ways you can do that in Dagster. You can take a cron approach. We also have sensors, which allow you to follow more of an event-driven workflow. And then we also have an SLA-based approach that we refer to as the declarative scheduler. And I'll touch on all three of those when we get to the live demo here in just a moment. And why this matters, again, it makes it easy to test versus in the Airflow or Prefect view of the world, sometimes it can be difficult to test the code that you've written. You just kind of have to deploy to production and see how things go. And because of the rich metadata that Dagster is capturing, you're able, again, to get a lot more insight into your pipelines at a top level, and also drilling into the weeds when things break down. Now, I'm going to jump over to the live demo here, but I'm going to kind of take a backwards approach where I'm going to start with an already curated Dagster project. I'm going to walk you through kind of the overview page, and then we'll look at the global lineage. And then from there, we'll look at kind of the developer experience. So I'm going to go ahead and pop over to the Dagster Cloud UI. And this is the overview page where you can see all of your pipelines and jobs that are running. You can see if they succeeded or failed, how long they took, and you can drill into one of the historical runs if needed. And you can see the individual run steps that occurred in that specific run. And we surface back to you the structured event logs. So if this was in a failed state, again, you could quickly identify the underlying issue. And if it was still in a failed state and you uncovered what the issue was, you could kick off a run from failure if you'd like to. Now, as I was mentioning earlier, the core abstraction in Dagster is a data asset. So I want to focus on that for a bit now. And if I select the asset tab here at the top, over here on the top right, I can navigate to our global lineage. And even just at a top view, you can see from the color indicators here that I'm able to get information about the current state of my pipelines or the assets themselves. And if I drill in a bit more, I get even more context about the assets. So if we start at the top here, this is kind of the beginning step of our pipeline. You can see that we have a couple of API calls that we're making. We're then lining that data into our data warehouse, and then we're doing some dbt modeling on top of that. dbt is one of our most popular integrations. I think something like half or a little over half of our customers are using it. If we scroll down here a bit more, you can see that we have some forecasting, some machine learning work that has been built on top of the dbt transformations. And then over here, maybe it's the case that you have like an embedded analyst team in your marketing group that's also doing some analysis. So the end-to-end lineage allows you to see how teams are collaborating with one another, and it allows you to also to see if you make a change upstream, what the downstream impact would be. Now, in the example that I gave just a moment ago, in how you're able to show tighter connections to the things your stakeholders care about, let's say that your stakeholder says, hey, the weekly order summary dashboard looks off. Can you look into it? I can already see the connections tied back to that dashboard. So I can start to glean information of where I might want to go troubleshoot. So if I start on this asset in particular, if I click into it, I get metadata about this asset. So for one, we get the model definition itself being a DBT model. You can see that we have a freshness policy set. So this asset needs to refresh by Monday at 9 a.m. And it looks like we got a green check mark there. We also surface back to the historical run duration for the individual asset. So if you see a spike or a dip in the time it took to run, that might be a good indicator of somewhere to troubleshoot. And if we keep scrolling here at the bottom, you can type partitions back to your assets and make Dagster aware of them. And if there was a missed partition, you would see that reflected here in this graph here. So if I were to select material I selected, maybe let's say that there was a missed partition, I can grab a subset if there was multiple missed partitions or an individual partition. I can also tell it to grab just the latest partition and then launch that backfill here in the UI. So we wanted to look at the historical view of those runs also. You can see that each partition kind of appears as its own, it's almost like a micro asset or mini asset itself, where you can see each partition has its own run logs as well. So again, if you needed to troubleshoot, you could certainly do that. And just kind of, I guess, emphasizing why that even matters. I can say I come from a data engineering practitioning kind of background, and it hasn't always been as easy to launch backfills. And in particular with DBT, for incremental models, often in my experience, I would have to kick off a full refresh or run some bespoke code against our production environment to launch backfill. So this just makes it a lot cleaner and safe to do without impacting any of your production pipelines. Now, I'll go ahead and pause there. I know we asked in the beginning, see how we're tracking, any questions, anything else that, any areas you'd like me to focus into? Which I think we had asset checks was one. And unfortunately, I don't have embedded ETL in this demo, but I can touch on the asset checks.
Yeah, no, that sounds great. I mean, maybe you could just talk to embedded ETL for the folks who didn't catch the content from launch week, which was earlier this month, or last month, actually, October.
Yeah, so we introduced some functionality that basically some packages that you can call into your Dagster project that allow you to do some lightweight ETL processing. So think like connecting to a database and then writing maybe to another database or to a blob storage like S3, for example. Embedded ETL allows you to facilitate the processes that an ETL tool like maybe Fivetran or Stitch would typically do. For whatever reason, maybe there's an existing connector, or maybe you're just trying to migrate some of those workloads to conserve costs. Embedded ETL aims to help kind of solve for that.
Great. And I just dropped the link in the chat for anybody interested if you want to dive more deeply into how these lightweight or this lightweight library solves a lot of data movement issues without having to rely on a really large, heavy third-party tool.
Yeah, thanks for that. And then on the asset check front, if I scroll up here to the top, you can see that we do have a check on our first asset here. And you can, there's a few different ways you can add checks to your asset. It can be, if you were talking about DBT, it could be one of your DBT tests could flow through as an asset check. You can write custom tests. We also have the ability to integrate with Great Expectations. It's a popular Python library that's exclusively dedicated to data quality. But you can click into the asset itself and you can see the asset check kind of output or success or failure here. And you can view in this instance kind of the historical runs. And if you wanted to view the metadata for one of those failed runs, you can also see that. So depending on what the test is that you've written, this is going to capture the records that failed that criteria. And it looks like there's a hand that went up.
Yeah. Do
Sorry, is there a question there?
you have a question, Marcos? If you're connected on sound, we can't hear you, I'm afraid.
All right. Well, if you're able to get your audio working, feel free to chime in. Maybe we can address it later on. But yeah, so the main thing here with asset checks here, though, is it gives you an extra layer of and able to ensure that you're shipping high quality assets, and that allows you to catch issues before your stakeholders do, which in turn typically erodes trust between you and them, and that leads them potentially not relying or using the assets that you're producing. So yeah, we highly recommend applying them to your assets, and it's another way that you're able to quickly identify when issues have happened. Okay, I see that hand go up again. Is your audio potentially working this time?
Yeah, we're not hearing you, Marcos. So I'd say drop it in the chat if you do have a question, and I can jump
Hello?
in.
Can you hear me?
Yeah, now we hear you.
Oh, I can hear you now.
Oh, Jesus Christ. Okay, yes,
Yeah.
thank God. So just a quick one. So this is the Dagster cloud version, right? Is this functionality available on the on-prem or the standalone version?
Yeah, the asset checks are available on the open source and on the cloud version.
Okay, so we currently using Airflow at the moment, and we're looking at moving to Dagster, and we basically have some complex pipelines with multiple data sources, and this is all on-prem, given its sensitive data, basically. So I was just wondering, how does this compare? It's probably not the right platform to be asking these stupid questions, but yeah. How does it compare, like an asset, to an Airflow task?
Yeah, that's a fair question. And so I think that's actually a good segue to talk about how assets are created. And this hopefully will help answer the question.
Thank you.
And
So
just quickly, while Izzy takes us through that, Marco, what I'm going to do is drop some stuff in the chat for you. We did a lot of work around migrating from DAGs out of Airflow and into converting them into assets in Dagster. So I'll drop you some resources in the chat. And
That would be great. Thank you.
Izzy back.
yeah, I if you are considering moving over, there also so in addition to because an asset view of the world is just a different way of thinking about how you're building your pipelines, and hopefully that will be clear in here in just a moment when I talk about how they're created. But
Yes.
also, if you're just trying to keep the lights on as you migrate to Dagster, we do have a guide here, migrating your Airflow DAGs to Dagster as well. That with minimal code changes, you can keep your Airflow DAGs or pipelines running versus having to convert them to an asset kind of view of the world.
Okay, cool. Yeah, we use Airflow, but we also use Task Scheduler. I know it sounds really ancient, but that's that's why we're looking at Dagster. So we got a unified orchestration engine, and I'm just trying to assess what's the workload of changes, or what do I need to change to convert this into Dagster pipelines. And because we already have Python libraries, so we got a compute engine in Apache Spark, and then we got all the code, all the logic is in Python classes, and that basically runs all the pipelines. Now I just need an orchestration engine then that picks those pipelines and orchestrates them.
Yeah, that makes a lot of sense. And so, as I mentioned, we do have this migrating Airflow to Dagster guide that walks you kind of an example of how you would move one of your pipelines over. But then I'm going to touch on now how assets are created. So any new pipelines, this would probably be the recommended approach in Dagster. Okay, so there's three types of assets that you can add to your project. The first is data that's processed in Dagster. So in this example, you can see that we have two assets defined, and an asset is just a Python function that has this asset decorator. And the definition name of your function is going to be the name of the asset that's produced. So you can see we have this extracted asset, and then we have this transformed asset below. And dependencies can be explicit or inferred. In this example, it was inferred because we used the extracted asset as an argument in the second asset. And so that's how Dagster is able to then construct lineage and infer those dependencies. Now, an example of data being processed in Dagster is like an API call where you're doing something in memory, for example. But another common use case is where you're just using like a Python client to run some code in an external environment. So as you mentioned, I think maybe executing in Spark or in Databricks or Snowflake or whatever, you're able to just call an external process, and then the actual data processing happens there in that external source. In this example, again, we have two assets that we've defined. We have extract and loaded, and then we have transformed in DB. And in this example, we've explicitly stated the dependency by adding this dependency parameter, and then you just specify the name of the upstream asset. So as I mentioned, again, those dependencies can be inferred or explicitly called out. And in the inferred example, you would feed it in as an argument in the downstream asset. Now, we also have a number of integrations. As I mentioned earlier, dbt is one of the most popular, but we also have integrations with some common ETL tools out there like Fivetran, for example. And I understand that it probably doesn't make sense to convert all of those jobs, or in dbt's example, all of those models to an asset as a Python function. And so these integrations help to simplify that process. So let's say that you have 100 dbt models in your dbt project. This line of code will convert those 100 dbt models to Dagster assets. So you don't actually have to map them one-to-one. This does that mapping for you, and then you still get the benefit of them showing up in the lineage graph. And then you can tie those back to jobs and schedule them at different cadences as needed.
So in our case, it's all SQL Server, so all really old-fashioned. It's sensitive data, so they're very reluctant to do anything in the cloud. So I was just wondering, how does that then compare to like a Microsoft SQL Server?
So it depends on, I guess, how you're planning on. Certainly, you could wrap SQL logic in an example like this here, where you're going to define your asset, and then you would call that SQL that gets executed in SQL Server. And I know you'd kind of distinguish between our open source and cloud, and in either instance, in either of those cases, you certainly can have the data run within your own infra, so like it never touches. Like on the cloud side of Dagster, you can certainly use. We have a deployment model that allows you to maintain all of the code and data within your own infra, and we don't have access to it. And in the open source version, that's obviously not an issue because you're already running Dagster within your own environment anyway.
Excellent. Another quick question, if I may, given I'm the one asking all the questions. Can you, and apologies for the ignorance, can you run Dagster in a cloud VM?
Are you talking about your own self-hosted?
No. So this is the company. So at the moment, we're using OpenShift. That OpenShift has a cluster. Within that cluster, it's sitting in Azure. So we basically got a cluster. What I'm thinking is having a dedicated VM running Dagster, so on containers basically.
Yeah, that's a common deployment use case. And as I mentioned, we have multiple deployment models. It might be helpful to have a follow-up conversation, and we can kind of touch on what the options there are. But that's
Okay,
certainly
cool.
one way of doing it.
Thank you.
So, and to your example of the SQL Server kind of SQL code, as I mentioned, you could wrap that into an asset like this, or I don't know if you're familiar with DBT, but DBT also has a SQL Server integration, and DBT models or transformations are all just SQL. And so I can show an example now. Unless there's any other questions, I was going to kind of quickly walk you through the development workflow with Dagster. And as I mentioned, Dagster was created to enable software engineering best practices. And so being able to develop locally, test your changes, and then make sure it's working before you promote to promote to prod. That was all intentional with from the beginning when Dagster was created. All right. So I'm going to walk you through a quick example, and I'll try to call out when there's nuance between open source and cloud. But what I'm about to show you would work in both instances. So I have VS Code here, and I've already stood up kind of a virtual environment with my Dagster project, and it's pretty lightweight, easy to get set up. You just do a quick pip install of Dagster, and in many cases, our docs will show you a walkthrough of the exact installs you need to do to get up and running. But this is my Dagster project here on the left. And if I wanted to kick off Dagster locally, I'll just need to run Dagster dev. And this is going to spin up a local instance of the Dagster UI. It will look very similar, except you can see here in the demo I was showing you, this is our cloud URL, and we were on this data engineering prod deployment. Now that Dagster dev just spun up this local host version of Dagster. And as I mentioned, it's going to allow me to make changes and then see those here before I decide to promote to production. So think of this as a sandbox. It's isolated from production. I can safely make changes and not impact or break anything downstream. So if we jump back to VS Code, I'll walk you through a quick example with DBT, and then also walk you through a quick example if you're just doing a vanilla Dagster asset. So in this example, to keep things super simple, we actually have nested our DBT project as a subdirectory into our Dagster project. And if those of you who are familiar with DBT, all of your DBT transformations will live under the models directory here, and they just get saved as SQL files. And then you can have additional subdirectories for organizational purposes. In addition to DBT allows you to quickly apply kind of configs to any of your DBT models following the structure also. So I've created this demo examples directory, and if I click into it, you can see we have my first model, and this is just some simple SQL where I'm just populating some dummy data. And now let's go ahead and add a second DBT model. And this example would be, this could be used for the SQL Server, as I mentioned. DBT has a connection there, or you could alternatively call it just in a Dagster asset itself. But I'm going to go ahead and create the new file, and then we'll just do a simple select all from our first model. So in DBT, You use ref or source macros to tie together your model. So in this instance, I'm using a ref macro, and it takes a single argument, which is just the name of the upstream DBT model I'm referencing. That's my first model right there. I'm going to go ahead and save that. Now, if I toggle over to the asset graph, again, we're on our local hosted version of Dagster. You can see that I have my first model here. Now, if I reload my definitions, it should populate my second model, and you'll also get the dependency there. So looks like it did come through. Let's reload it one more time just to make sure that we get the dependency between the two. So you can see now in my local version, of my Dagster pipeline, I've added a few new assets that I don't yet have in production. I can test that they're working here before I decide to open up a pull request, again, enabling those engineering best practices. So part of that, I probably would make sure that it's running as I would expect, so I can kick off a materialization here. It's gonna, by default, unless you've specified a connection otherwise, it's gonna just use the local file system and pickle, it'd save them as pickle files. And you see it looks like that worked okay. And now I want to show you a quick example of what a Dagster asset might look like. That was a DBT example. So if we pop back over to VS Code again, now let's collapse our DBT project, and we'll navigate to this data engineering subdirectory or subfolder. And under assets, this is where you would store all of the assets for your project. And similarly, you can have subdirectories to better organize the asset. A common practice is to tie them back to like the business functions that you're serving. So in this example, marketing, for example, or forecasting. And I have this example assets directory I've created, and I've created, so this is the one that we're seeing in the UI already. It's just this, again, just a simple example. I don't have any complex code here. We're just returning 1, 2, 3. Now, if I uncomment out the second asset, you can see that I've used the upstream asset as an argument in my second asset here. If I go ahead and save that, now I'm going to go ahead and reload the definitions again. And you can see now that we have that new asset here as well. So again, the local development is a great way for you to test your code before you decide to promote to production. Again, and you can add tests along the way. You can add asset checks that we kind of mentioned earlier. But again, a great way for you to ensure that your code's working and that you're not introducing any bad code into production. Now, one thing I want to highlight, now this is a distinction with Dagster Cloud. Dagster Cloud helps to automate the CI/CD portion of deployments, and there's this concept of a branch deployment. So let's say that I tested this, my code seems to be working as I would expect. I can now open up a pull request to merge it back into prod. And I already have an example pull request open here. Admittedly, it's not, I don't have the same assets that I was just demoing here. But just to articulate an example of what this would look like, we're using GitHub in this example, and there's a few checks that run to ensure your code's working. One, that there's no bugs, that the syntax is correct. But then you could certainly set up a rule that would block the pull request from being merged in if either of those checks failed for whatever reason. But that said, I want to call your attention to this GitHub action here. Where we have an integration that this is creating a staging environment. Think of it kind of an ephemeral deployment that I can validate that all the code's working in a production-like setting. So if I open this in a new tab, you can see now that I'm back to our cloud UI, but I'm no longer on that data engineering production deployment. Now I'm on our add marketing KPI, which is tied to the pull request that we opened here in GitHub. So similarly, if I navigate over to assets, I can get the lineage here. I can test things that are working. Again, a common practice here for branch deployments is to have this read from or clone like your production environment, but then write to a distinct area or a distinct schema, or even maybe a distinct database, depending on what you're doing under the hood. But again, just another layer for you to test that your code's working before you actually pull the trigger and merge back into production. And once you're ready and you do merge in the pull request, a similar process would then automatically deploy that code to your production environment.
Hey, Izzy, there's a question that came through here from Biodon, talking about cloud. So we have the hybrid deployment, right, where Dagster Cloud, where you have your own instance, but you're able to tap into your infrastructure, so all your data stays secure. We don't get to touch that. Do you have best practices around exposing metadata when using Dagster Cloud? Like, how would we tap into that? The question is, I'd like to use the cloud version for scheduling, but they have sensitive data.
Yeah, I don't know that we have best practices for metadata, but we do have an example here that kind of talks to the type of metadata that you can surface back to your assets. So for example, information about the asset itself, so you can surface back a row count or other data profiling type metrics. You can also, as we kind of alluded to earlier with asset checks, that type of information, metadata of the success or failure of those asset checks. You can also, if in some more complex use cases, like if you're doing machine learning type work, you can surface visualizations back as metadata. But yeah, there's a lot of flexibility there. I think we stop short of recommending what you should or should not provide back to your stakeholders, but you do have a lot of options of what you can bring back to the table there. That said, in the Dagster Cloud view of the world, a bare minimum amount of metadata is needed in order to make Dagster Cloud work, and that's metadata about your Dagster project to display the global lineage here, for example, other metadata about like your jobs and the structure, to ensure that, again, we can orchestrate things as needed. But as I alluded to earlier, there's a couple different deployment models for Dagster Cloud. We have a serverless model where we host all the infra for you, and then a hybrid model where we manage the control plane, and then you would install an agent in your environment. Common examples are like a Kubernetes deployment or Docker. In AWS, that would be like EKS or ECS, for example. But in that example, in the hybrid architecture, we don't have access to your code or your data. And again, you have flexibility around what metadata you bring back to or surface back to your stakeholders here. But at a bare minimum, we would get the metadata about, again, the structure of your project and like the success or failure of your runs, things like that. So you can manage your pipelines. So hopefully that answers your question.
Yes, it is. Thanks.
Yeah, that's great. Thanks. And what you'll also see if you've been tracking some of the new features that we've been releasing is that Dagster really is evolving, not just to manage and orchestrate these pipelines that you've defined within the context of Dagster, but also to observe and pull in metadata from external assets, as we call them, which now gives you much greater span of control and observability. And that was really something that is missing in other orchestration platforms is, they call themselves, or a lot of orchestrators will call themselves a single pane of glass. But it's not really the single pane of glass until you can look at all of the assets in your data ecosystem. And that's what you'll see as part of the release that we announced just a few weeks ago.
Yeah, that's actually a great call out. And I think it's super relevant to, I think it was Marcos, whoever was using Airflow. That's one of the kind of targeted use cases there, is that it adds another option for integrating your already existing Airflow pipelines with minimal code changes and get them running in Dagster, or at least metadata about them if you use an external asset so you can see the status of those pipelines. I didn't touch on it here, but in our forecasting example, this Databricks asset in particular is an external. It's using pipes. So this code lives in Databricks, and we're just calling it with our recently launched pipes functionality. So again, we have a lot of cool features that we just recently kicked off, and depending on your use case, might be relevant. And in particular, I think it would be relevant to the Airflow stuff. But that said, that's kind of all I had to showcase, kind of walk you through the development workflow. I don't know if anyone had any other kind of areas they want to drill into, but yeah, I'm going to go ahead and pause there.